All right. Turn this off. So we're going screen only today. No camera. But you can watch over my shoulder, so to speak, and hear me on the microphone, hopefully. Whoa, too big. Okay, let's see. All right. And I am jumping into the intersection stuff that we worked on Deep Dive. So if you're interested in this and you want to see more of similar stuff and you haven't already watched it, you can find the Deep Dive from this past week. And I worked on some of this stuff as well. I won't go into a super deep overview of what I did back then, but the really quick version, if you didn't happen to catch that, is I'm working on some functions that will tell you whether or not some geometric shapes intersect. So we have circle and rectangle, as well as like rectangle, and circle implemented so far, and I'm going to add a few more today, is the goal at least. So ultimately I'm trying to get to polygon. Polygon circle intersects, and then like polygon rectangle intersects wherever that's at. These are Python implementations of them that are working pretty good as far as I know. But we're trying to add this to the core is my plan here. Some of these are a little crazy though. Some of them do venture into NumPy territory where like when was it? It was line and point, I think, right? Line contains point. So this is doing some like NumPy type stuff here. I don't know how easy this will be to do from inside the core, but we'll have to cross that bridge when we get to it. I'm going to start with some of the easier ones. In fact, I'm going to start with rectangle contains point. Rect, which actually is not here. Interesting. I guess that one did not end up being needed, so I suppose I'll start with this instead. Is that true that that was not actually needed, though? These all, again, came from Jeffrey Thompson, collision detection. I mean, there is a point rectangle, but the real question is, does that get used by, like, polygon rectangle? Because that's ultimately what I was doing. But I guess that only needs like point inside polygon, not point inside rectangle. Yeah, polygon point, which is the part that they say is optional. Turn it off if you don't need it. Although I will mention the way they do it is not necessarily... Well, maybe it's better than I was thinking. I was thinking they did this after the loop. And contains points, so they're looping through the vertices. Getting lines, basically. I gotta find cat distractor. And also use the cat distractor for a minute. Lest my legs become the cat distractor. Okay, yeah, I guess this it didn't use rectangle point, so I did not implement that one before, but there is a rectangle point on this, in this book, on this page, which I think is pretty easy, right? Because it's basically just check if it's to the right, check if it's to the right of the left edge, check if it's to the left of the right edge, check if it's below the top edge, and check if it's above the bottom edge. And if all those things are true, then the point is inside. And that's all relatively basic stuff. So we could eventually add that as well. But since I do have circle point already, let's do that one first. Circle contains point. Do I want to call it contains like that? Or do we want to go with like circle point intersects so that they all fit the exact same naming convention? Or should it be point circle? I mean, I suppose intersects in the middle would maybe make more sense anyway. Circle intersects circle. Alright, well, let's not get too bogged down in the what to name it. I will just take circle circle. I did go back and fix the doc strings a little bit ago. I'm gonna do circle contains point. I kind of like that. Contains point. We only have one circle, so we can just do CY, CX, CR, and then we will have PX and PY for the point. And we don't need this one. Try to fix these as I go so I don't end up with another chunk of time just working on that like I did earlier. Checks whether circle contains the given point. These are different too. Like I deleted one extra thing there than all the rest of them, but I don't know. It's PY. Do we need? Oh, we need the int. Okay, that's why it's. We don't need that though. I don't think. Yeah. Name and then type. Whereas down here, it's type and then name. Plus, you need param also. I suppose we should fix these. Goal. Point x. Oh, also, I just said earlier, I don't have the chat open really. I have some of the chats open, but I'm not watching them as closely, truthfully. It looks like we haven't had anybody say anything, which is good. Bad if I was just ignoring somebody. Oh, James actually on YouTube says, what are some practical uses for that library in Python? My bad. I don't know exactly how long ago you said that. Some practical uses for the library in Python. So like the most practical use case that I have in mind is games. Like for instance, the game Breakout. If you're not familiar with it, I don't know. Breakout game. Basically, a ball bounces around and tries to break some bricks. I was working on a version of this game for CircuitPython, and that's when I basically first got interested in these intersection functions. In these ones, I don't need all of them, right? In this, I pretty much only need circle intersects with rectangle, right? Because the ball is bouncing around. It's going to hit the bricks, and it's going to hit the paddle. And I need to check for those two things, but otherwise, it's kind of like I don't really need polygon or anything else fancy for this. But I figured while I was working on the circle and the rectangle ones, this really nice resource that I found also has the polygon ones, and then Vector.io, which is a CircuitPython module, does contain the ability to create polygons to draw on the screen. So I figured it'd be good to match the shapes that are available with Vector.io, since that's where I started putting this functionality as well as in the Vector.io module in CircuitPython. I don't know how familiar you are with CircuitPython or any of the rest of anything I just said anything about. But if you don't know what any of that means or what some of that means or whatever, feel free to ask. I can expand further. But yeah, that's my intended use case is games, basically. Yeah, for sure. Okay, circle contains point we went with, so circle contains point. Pick the arguments, parse the arguments, fix all of these. Nice thing is that we have some of these that are like sort of similar enough that I can just add a bit and take out a bit and we get basically what we need. So we'll call common how Vector.io. That's going to be circle contains point. Contains point. Fix the arguments. Return true false. Yep, that looks good so far. We can fix this part. Circle contains point. Okay. So we need to define this now over in shared module. Probably we need to do some more stuff too that I'm forgetting. Like we need to do the thing in here, I think, right? Yeah. Need to do this thing. Circle contains point. Contains point. Got an empty line still. CX, CY, CR, PX, PY. Okay. Circle contains point. Okay, good to go. So now we need to make this over here. We need anything in here? I don't think so. Yeah, it doesn't look like it. I'm gonna copy circle circle again, because that's pretty close to what we're doing, and that's been working out alright so far. Circle contains point. So we can fix all of these the same. Get rid of this one. Alright, we don't need those bits. And we don't need this stuff here either. So I'm just gonna get rid of this. I'm gonna put false for now. I'm gonna get rid of this. Then we're gonna take the code from actually the Python implementation, because that's easier for me to follow. Which is in here, here. I'm just gonna drop this in as a comment so I can look at the Python implementation right next to the C implementation. That's the wrong way. That's the wrong shift. Okay, so we need to get the distance from the point to the circle's X. We need to get the distance from the point to the circle's Y. Those are going to be these things, pretty much. So we could actually just copy these. So I guess I could have kept some of that stuff. Whatever. Distance X, so that's actually the PX minus the CX and the CY and the PY. Then we need to get the total distance. Yeah, I probably should have kept some more of this. It's fine. Get the total distance. which is going to be done a bit differently. So here it's using square root. So distance x squared plus distance y squared, and then take the square root of that. That's given us the full distance, and then that's being compared with the radius to get the final answer. But one of the things we were doing the other day when I was converting these was getting rid of the need to use square root and instead leaving this as distance squared, although we didn't call it that, we maybe should have. And then when we do the comparison, squaring the right half of the comparison, which doesn't take as much power, I guess, as square rooting in the computer. I think I am going to go ahead and do that. Dist square. I'm just going to start with this one, but I'll probably eventually go back and do those as well. Distance squared is going to be probably the same as this, actually, right? Because this is the same as inside of here, and it just doesn't have the square rooting on it. So yeah, that looks good, actually. And then the return is dist minus equals circle r, but we want to do circle r squared. We don't really need this, I guess. Circle r squared, so we're just going to times it by itself. And then I think that's everything we need. Probably I'm wrong, but we'll see. Let's try to make a build. That's not making a build. There we go. All right, actually, while this one's running, because I assume it's going to be a longer build, I will BRB. Okay, definitely failed. Looks like we didn't change some of those things. Let's see. 218 init inside of shared bindings. Ah, yeah, these need to be fixed too. All right. Well, hopefully that didn't fail immediately after I left. So I was gone a minute to change the laundry too. But back now. Back on the road. Still no. Okay, different error though. Good thing. Dist is undeclared. Okay, yeah, we need to like declare that, right? This isn't just Python. We can't just make that and then it exists out of thin air, I guess. Oh, well, I changed it to dist squared actually. That's the problem. Also, these are wrong, right? We have CR. So maybe we shouldn't. Oh, okay, that came from here actually. Right, so that's the processing code, or that's the Python code. I'm just gonna keep it small. Oh yeah, that doesn't work in here. Control W doesn't work, code folding doesn't work. There's a bunch of stuff that I've noticed doesn't seem to work inside CLion with the CircuitPython project. I don't know if it's specific to the CircuitPython project or CLion. I was trying to look around, and it seems like the CLion docs seem to indicate that code folding is a thing that exists in there, but it's not working for this project. Okay, we actually did get a build. Bootloader, copy. I think I saw copy back here, yep. Yeah, okay, we'll let that copy. We'll see if we completely wrecked everything or not. No, looks like we didn't completely wreck everything, so that's good. This one is still not actually testing the new code. Let's change the static shape to a circle. This is back in Python land, CodePy. That's the wrong CodePy. CodePy. Okay, let's go back to static circle. And then let's change the test down here. If a circle contains point, so that will be static circle X, static circle Y, static circle radius, and then we just need the point, which is way less than all of this. What is going on? For the point, I'm just gonna use the top left of the moving rectangle. Gonna try to, at least. Oh, okay, missing this. There we go, okay, yes. So this will be, if the top left corner of the moving rectangle is inside the circle, then it should change colors. The moving one. Or the static one, I don't remember. The moving one. I'm gonna have TU open. Circle contains point. Okay, yeah, we forgot this thing. Inside shared bindings, we need to add it to that list at the bottom. I'm gonna close some of these. I don't really need these anymore. Yeah, this thing. Map. Globals table. Makes sense. Okay, let's make a new one of these. Actually, let's make a new one of these. Make a new build. Theoretically, we could try to go back to bootloader mode right now while this is building, but I don't trust it all the way. I don't like to let it just do its build and don't worry about anything else. Aside from recording the stream and streaming and playing music back to my ear, which is already kind of a lot. Definitely a slow build. Sometimes you can, if you only change certain stuff, sometimes you get really fast builds. Especially the Raspberry Pi port for Pico is like, I've seen them go really, really fast, like 10 or 15 seconds. Super fast for CircuitPython build. Although even the slow ones here are still faster than like Espressif build with the ESP IDF has to do a lot more stuff, I think. Takes a while to build. Okay, got another one of those. We can go to bootloader. Copy. Okay, so should be top left corner. We should drive this around, and only when the bottom corner is in, it doesn't change. But if we get the top corner in, it should. If we poke it out the bottom, it should go back. Looks like that's working good. So if we wanted to do rectangle contains point, would it be easier to copy this or like rectangle, rectangle? I think we copy this and then we copy a chunk from one of the rectangle ones. I'm gonna use the mouse. So rectangle contains point. Find one with a rectangle. I'm actually going to go specifically to circle rectangle because that will have RX, RY, RH with no 1. Point is there. We're going to replace all of these. Replace all of those. And that's pretty good, I think, on the docs. Check whether a rectangle. Wait, what? How did we lose the X? What is happening? I think I didn't copy enough. There we go. Okay. Okay. Ouch. I think we're ready to close that. Go back down here. And we need to add it to this thing. Let's not forget that this time. Globals table. Then we need to go to shared module and ditch the Python implementation. Can copy the C implementation. We need to go to the H file also. Okay. I'm going to do the H file before I forget. Alright, so this one's pretty easy. I don't think we really need this. It's basically just like, make sure it's above the X of the rectangle. I mean, make sure the X of the point is above the X of the rectangle. Make sure the X of the point is below the X of the rectangle plus the width of the rectangle. And then same for the Y. We gotta remember the Y is flipped, but that's fine. We don't need any distances. Should we make like... I guess we make different if statements and we return false from each one if it dissatisfies the condition, but then down here we return true if we made it through all the other ones and haven't returned yet. So if the so in this case we want to test for negation, so in this case we would want the point be outside the circle, which would mean the Rx is actually greater than the point. And in that case the point is to the left of the rectangle, which means it's not inside. So then we can check if it's to the right of... So I'm going to go if px is greater than to the right of rx plus rw. Then we return false because it's outside the right edge of the rectangle. And we basically are doing the same thing for the y. So if the rectangle y is above the point y, is that correct? So rectangle y would be the top of the rectangle. Yeah. If the top of the rectangle is above a higher pixel number, that means it's further down the screen. If it's further down the screen, that means the point's on the outside. And then this one, basically the same. So it says if the point is greater than, so below the rectangle y plus the rectangle height, then the point is below the bottom of the rectangle, so we return false. Yeah. Sounds good to me. And if all of those are false, then we return true because we know the point's inside. Our indentation is a little messed up here, though. We're going to go like this. Let's just not let us do that. Okay, well, fair enough. Indent one line at a time, just not multiple? Fascinating. I guess that's how all of them are. All of them are new ones that I made, so is that the right way? That part I don't know. I'm going to leave it for now, though. If you look in here, maybe. No, this is shared bindings. Yeah, it is the same. Those are indented to the same level as the code. There's not technically an indentation after curly bracket, which is a bit weird, but that's how it is. All right, I think we did the H, we did the globals, we implemented this. Oops. Forgot to change that. Forgot to change these, it looks like. Whoops. Oops. We updated the docs, but not the things here. Let's find argrx. Somewhere else, though. Oops. Gotta make the build before we can copy it. Alright, while that's running, let's look in the Python code for a minute. So, line contains point. Who all uses line contains point? Line circle intersects. Is that the only one? But that gets used by polygon circle intersects. So polygon circle intersects needs line circle intersects. Line circle intersects needs point. Line contains point. And line contains point needs all this numpy stuff. Is it the only way to do it, though? Or did I change that at some point to use numpy specifically? I think I might have changed that at some point to use numpy. So I was like, maybe there's a way to already do this. In which case... Is there a reason to implement this one into C? I mean, the reason to implement it into C is to be able to call it from C so that we could have polygon intersect circle. So, but then if we do implement this in C, we could just use the simpler thing in here though, right? Instead of all this linear algebra normalization, okay, so dist we have now. That's been added to math recently. So this is getting the distance of the line. It's getting the distance of the point to each end of the line. And then it's adding those distances. And if it's equal to the length of the line, then we're on the line. Yeah. Which does make pretty intuitive sense, I think. And this also gets a padding. What I call a padding value, what they call a buffer value. Which is basically like a slip factor. No. Come on now. Not published to chat. Okay, that's good, I guess. How come it stays visible to me after I ban them? How do I close this? Just went through this the other day. Oh my gosh, how do I close this? Oh my gosh, Twitch, you're killing me. How do I close this? Why is there no close button? Okay, we made it. Alright, it was a battle, but we made it. Okay, yeah, so this is coming back to me a bit. I switched this to use NumPy. I should have left. I should have. Well, okay, so really what I did is, I mean, the formula is roughly the same, right? Distance of the line, distance of the point to one end of the line, distance from the point to the other end of the line. What I really did was change the way that we calculate the distance. In this code here, in the processing one, it kind of glossed over it with dist, which led me down the path towards finding math.dist, which I then added to CircuitPython. But before I had done that, I also looked into other ways to calculate distance. I think I searched something like how to calculate distance with NumPy and found this other implementation that uses this linear algebra stuff. So then I went and tried to swap that over to use this stuff. In essence, making this function faster, probably because it's now doing its math in NumPy. Although I didn't actually profile it, so I don't actually know. But we can just go back to the straight distance. Well, I mean, now we have math.distance, which is just using what I would call the normal distance function, not the linear algebra NumPy one. Okay. That's actually going to be a lot easier to do. We can just grab this, I think. Oh, rectangle contains point. Did we test that? No, I didn't test that, did I? Okay, let's not get ahead of ourselves then. Oh, we made a build and then I switched to the Python code. I got distracted. Okay, so 64 inside shared bindings. What is this? Probably didn't update these things. This is, wait, this is back on circle rectangle intersects. What? These should be fine. I didn't touch these. Conflicting types? Where circle contains point. Oh, I probably didn't update the name to something. That says common how. That makes me think I probably didn't change the name here. Rectangle contains point. We did though. And it returns a Boolean. Conflicting types for circle contains point have bool, aka bool, bool. Line 60 shared bindings. We just duplicate it? Okay, so 60 inside shared bindings is circle rectangle intersects. Okay, I'm just gonna go make clean and make again and see if we get the same thing again. While that's working, I'll still try to work this out, but maybe it's just a fluke because this is not really lining up with the code. Why does this say have? So have bool. Okay, those are the arguments. So returns bool, accepts 1, 2, 3, 4, 5, 6 ints, which is wrong. We should only have 5. Right? Because CX, CY, CR, PX, PY. Okay, did we get the same thing again? Yeah. Okay, probably I have the number of arguments wrong somewhere. But I don't know why it's pointing to line 60 or 64. That part seems weird. I also don't know why this is now back on the circle one when we tested the circle one and it worked. 1, 2, 3, 4, 5, 6. Common how vector IO rectangle contains point. And circle contains point is this one, and it has 1, 2, 3, 4, 5. Did I mess up the H file? Maybe I messed up the H file. There it is. Okay. Oh, I was looking in the wrong file. This says H, not C. Yes, reading is good, I guess. Okay. Duplicated this name without changing it. Rectangle contains point. There we go. .h. Okay. Bootloader, copy. And we want to swap back to static rect. Oh boy. I don't know why that happened, but that's not what I wanted to happen. Oops. Okay, so we'll do the same thing where we're testing against the top left corner of the moving one. We're using the static rect as the rect. Auto reload's not on, so we'll need to do that. Nice. Yeah, it's good. Okay. Running out of coffee. All right, let's do add line contains point. And we'll see what's next after that. I may stop after that. Not necessarily going to stream a full 2 hours or anything crazy. How long has it been? It's been a little bit under an hour. Yeah, we'll see how I'm feeling after one more. Let's see. So we want line, line point. I'm going to copy rect point because rect is rx, ry, rw, rh, and then px, py for the point. Line is going to be x1, y1, x2, y2, which is also 4 things. So that makes this kind of a convenient one to copy, I think. Not sure if 2 lines. It is. Line contains point. So vector.io does not have a line. You can't draw a line with vector.io. I think maybe display.io shapes has a line, but not vector.io as far as I know. But if we want to have the polygon stuff to work, then we kind of need this one. All right, there we go. Checks whether a line contains a given point. However, there is actually one more. There is one more on this, the padding. Which, do I want to put the padding in right now, or should we come back and add it at the end? Which is pretty much how I think I did it in the Python implementation. Let's come back and add it at the end. So that is the line x1, line y1, line x2, line y2. line. Fix all of these. I'm mostly skipping adding the padding right now because I don't have a float argument to copy from right away. I'll need to go find one of those or guess the right way to do it. Actually, I think math.dis took floats, so I could look at that. Pretty sure that took floats. Oops. Okay, yeah, and then we'll add the float later. Need to add it to this. Need to add it to H. Need to make sure not to keep the wrong name this time. R line? Okay. Oh, hold on. I don't want to copy this. I want, yeah, rectangle contains point. That's pretty close. I think if we had this exact thing back there to copy, but I don't think we do. Not the exact. We've done, obviously, a bunch of versions of the same thing, but those are slightly different with int16t. All this is different. I'll just leave return true for now, but we'll fix it. So x1, y1, x2, y2. Okay, we should be good there. Should be able to build here if I did everything right. Would obviously not do anything. Would just return true always, but guess it's good to know if I've already messed something up. Keyframe setting. I don't know where to find that. It's OBS somewhere. Maybe we'll get a fast build after this, since we did this one first. That'd be nice. Alright. We're on the right track. We have not messed up any names, at least. Okay, so we want... Just gonna go back to this one, actually. Endpoint. We want the line length, and then we want the distance from each end. So the weird thing about math is that it doesn't have a thing in shared module. So dist is just here. So we basically need to call this instead of, well, we need to call this, we're going to get back a MicroPython float. Need to, probably going to have to turn that into a C float somehow. Probably the same way that this works, in fact, actually. Oh, this can do multiple lines out, or multiple points at once. Wait, no, it can't. But it accepts its arguments as tuples. It can do higher dimensions, though. That part is true. This one can't. The one in CPython can. But it does take tuples, which is actually a little bit rough for us because we don't have tuples. We have x1, y1. Maybe we should change that. Probably we should just change that to take tuples instead. Like, so we're going to end up with like P1 coordinates, P2 coordinates, or whatever, for point 1, point 2, for each end of the line. We have to redo a bunch of this. Yeah, it's going to be way easier if we take that as a tuple, because then we'll be able to just pass it straight into math.dist there, get the results back. Otherwise, we're going to have to take these 4 things, build them into 2 tuples, and then pass them into math.dist. So we can just cut that part out if we accept the tuples directly. Which, like, we didn't for rect and circle and stuff, but we're gonna for this. What are we gonna call those? Maybe, what if we said P1XY? Is that weird? And then P2XY? Then we'll end up with 2 less of these. Oh, but yeah, we probably don't want to call it P1 and P2 because we already have point. We already have PX and PY for point. Line point 1? LP1? Or LE? LE? Line end 1? LE1? I don't know. This doesn't do the old tuple deal, like allowed args thing here. I'm not sure if that's a real thing or not. Oops. See if I can find a function that takes a tuple real fast. destination clip on RotoZoom. Okay, resume, test click, clip. Line ending one, XY. Line ending 2, XY. And point X, point Y. And then this does just do a parcel pretty much the same way as all the other ones did. So I think we should be fine with that as long as we set this up right. Then I think we should be okay. Okay, so we will need to do this part different though. So we, instead of just being able to say like args like this, we're gonna have to get these. Well, are we even gonna need all of these? We don't need, yeah, no, we don't need these broken out like this. This is the old stuff. Well, it's not the old stuff, but it's kind of the old stuff. Oh, I can't do that. Okay. Can I do that? No? Okay. Well, that's... For some reason, C-Line does not seem to like the CircuitPython project. It's a bunch of like... I don't know, I guess you could say advanced. They're not that advanced, but the more advanced like IDE features don't work. Like code block, for instance, or comment block, rather. Just trying to control slash for comments, or control shift slash for comment block, and neither of them work for some reason. Well, okay, so really what we need to do is we need to pull these off the same way that it would in here, which I guess doesn't really happen. Or does it? It does, right here. It's not really taking those out of the tuples inside of here. It's just passing them to this thing. I'm gonna go out on a limb and guess it's not like defined in here. Actually, it is. Okay. Extract tuple. That sounds convenient. Okay. So this is weird. So this takes a function. I mean, this is a function. It takes a bitmap. We don't care about that. We're not doing bitmaps. It takes a tuple object, and then it takes these two ints, but I guess this makes it a pointer instead of the int by itself. I'm not sure if that's the right terminology all the way. But we get the tuple, we get the two ints, and then it's like unpacking it, so to speak, here. So take this tuple and store the two values into here and here. And in this case, it looks like it's just adding some other values too, which we don't want to do in ours. Okay, so if we make an int 16t, two of them, and then we call this extract tuple, and we pass in our tuple and our two ints, my expectation is that those two ints are going to get filled with the values from our tuple, so we're then going to be able to use them. Do we need to keep using them with this? I don't know if we'll, because this is like, because of the way these are getting passed in here, I think might make it different. Honestly, though, all of that stuff is going to be inside of here, I suppose. At this point, all we're doing is just... Well, is it? I don't know for sure. I wonder where this came from. Oh, that came from here too. Okay. We're not going to be able to just call this super easily. And while it does seem kind of convenient to use, if we could, since we're not going to be able to super easily, I think I'm just actually going to look more back at the math code, which just does get array fixed to. So that turns the tuple into an array. P items and Q items in this case. Okay, I think ampersand is actually maybe pointer, not star. Get float, get float. Okay, then we can access the values like this. Okay, I'm gonna do it more like this, I think. But we do still need... we need something analogous to this, I assume, right? Okay. It does do this, but it passes it straight into here. We're going to take just this. That's a MP object T. The name of which is LE1XY. LE2XY. Okay, and then here we now have our objects like P object and Q object. So we're going to go LE1 chords. And then LE2 chords. Okay. Do those tuples get passed through to the common HAL, though? Oh no, those tuples don't get passed through to the common HAL. Just the values. Alright, BRB, I gotta run to the restroom. Okay. We might be in a bit of a pickle here. So my intention is to use that math.dist function as part of this line contains point, because we need to calculate the distance between a point and, well, we need to calculate the distance between all three distances between three different points, basically. So math.dist would be good for doing each one of those. We can do that 3 times and we'll have our 3 distances. Problem is, math.dist is expecting to be called from Python land, and it is expecting to get 2 Python tuples, MicroPython tuples. It then converts them to C arrays, does math on them, returns a MicroPython float result. So if we want to call this, we need to have MicroPython tuple objects. So, but the thing is, we don't want to calculate, well, I mean, the way I was thinking, at least, we don't really want to calculate those distances inside of shared bindings, really, honestly, right? Shared bindings is really just get the arguments from Python land, convert them to C constructs, and then pass them to the shared module code. And the shared module code should do the actual computation. So this really boils down to R and my instinct, I guess, seeing this here makes it look like, I mean, I don't know that this is showing the intention of CircuitPython necessarily, but it makes it the decision was made here to change these to single values instead of tuples. Which, if we were to do that, if we were to switch those to single values for our use when we pass them into here, and we were to go back to like this, that means that inside of this shared module code, when we write it, it's going to have to take these and put them back into the tuples in order to pass it to math.dist. It is boundary fill. That's funny. I was just thinking, so I actually implemented this boundary fill function a long time ago. I mean, a medium time ago, I guess. And I was remembering that it does use tuples inside of here. Arguably, it doesn't, like, maybe arrays would be better, I don't know, but this is at least an example of creating a tuple inside of C, shared module even. Maybe it couldn't be an array because it needs to keep growing, which like sounds counterintuitive because the tuple can't really grow either, but it creates a new one every time at the new length. Really what it wants to be is a list in Python land, but we're not in Python land, we're in C. Okay. So I will say that does bring me back to not using the tuples here because there's no point in passing in tuples if we're not really intended to pass them through here, which I'm kind of picking up that that might be the case. Not entirely certain that we're intended to make them inside the code like that other code is doing, but that other code did get submitted through a PR and reviewed and everything, so it must be at least partially okay. I wish, man. It's too bad we can't. I mean, we can. Guess we can probably find this if we look. In fact, it's right there, so that's convenient. We're going to go back to these. We're going to go back to these. We go back to passing in all 6 of those. I'm missing this bit here. Yeah, that was wrong anyway. All right. Already have that. Alright, so we were already to here. That's right. I have some of this. So we need to create those tuples. Our tuple length is going to be hard-coded, because it's always going to be 2. We can create this object. I'm going to call this LE1 XY items. And LE2 XY items. And then MP object tuple get new tuple. Yeah, because we don't want to do a get just yet. In fact, we may not even really need to do a get. We want new tuple above point. What is above point? Above point is object T above point equals tuple items 0. Yeah, so actually this has a list of tuples. So do we really? Yeah, I mean, I guess we do. It seems weird that we need a list to create a tuple. I have no idea why this one's going through here. The other one's not. Nor whether or not that is necessary. A new tuple. Wait, but what are these? We had tuple length, tuple items. Tuple length, tuple items. I don't know what those are. Or really why the size would be dynamic like this. Especially if we do actually have that list. Yeah, I don't know. We might be needing this thing. I don't know. I might not be making it through this. Truthfully, I'm losing steam pretty fast. My length is going to be always hard-coded to 2. But I don't even see, where was that length getting used even? So I'd get tuple. So those are the only 2 places this appears, and it's hard-coded to 0. So it's 0, and then it gets passed into here, presumably still 0. Why is it even a variable and not just 0? Well, okay, this is populating it. Okay, yeah. I think this is populating it. This is getting it off the list, getting off the object, whatever object it is, because here it doesn't know. It's getting that object off the list. This code is saying, take that object we just took off the list and turn it into a tuple and store it. Store the items in this and store the length in this. Okay, so we do actually need both of these. But that's only if we started with a tuple, which we didn't. Right? This is taking a tuple that came out of a list from Python land and turning it into a tuple, well, turning it into these things so we can use them. But we don't really need to do that. We need to just create a tuple and pass it in. Which was more like the one we saw here. So this one just takes the hard-coded number and the object list. Okay, so that's gonna return. So I'm gonna say mp obj t le1 xy tuple equals this. We're gonna get rid of these for a minute. Maybe they'll come back, maybe they won't. All right, does that even compile? Let's start there. No, not at all. Oh, but that's because unused variable. That's not so bad. I don't think this will work. Let's see. P printf or something? I don't know off the top of my head. I was hoping the autocomplete would kick in, but it didn't. I don't know. Git grep mp. I'm pretty sure it's like mp printf. Yeah, that's what we want. How's it going, Abaddus? Let's see, so print this string. Let's just print one of the values from our tuple. Weird, today's not Friday or Saturday. Truth, yep. One of the rare pop-up streams on a different day. Monday. Today's a Monday holiday here in the US, so off of work, but still itching to work on some CircuitPython. I was, so decided to pop the stream on in addition. Yep. So we should be able to just grab, well, what do we want this? It's just, I don't know what this is. Maybe let's find a different example. D. I think that's more like what we want. Been trying to convince people to move to CircuitPython. Nice. It's pretty awesome, if I do say so myself. Perhaps biased, but... I don't know if I can actually just do that. It might not actually work, I don't know. No. Invalid use of void expression. Maybe I have just messed up parentheses. Possibly that could lead to the rest of the problems too. Been pretty happy with it. Some weirdness with HTTP web server stuff. That could be my code. I need to troubleshoot more to be sure. I hear you. I've had some weirdness as well on the web server stuff, particularly on projects where I was really pushing the limits. I think in terms of memory, I started to get some weird stuff going on once I got up pretty high in memory usage. I was trying to do like templates and server stuff and all kinds of stuff. WebSockets. This one, void makes pointer. Utilization. Third module. Okay. Guessing that means these are not allowed exactly how we have them. Maybe we need these things. We don't have tuple items yet. So I guess this will just be x1. But I don't think that's going to be right either, though. Maybe. We don't need -1. Stack compile. No. Referencing void. Oh boy. Okay, we have a lot of problems now. Okay. Yeah, I think I'm not gonna make it through this really. Right now. Do we need this part? What happens if we try without this? Okay, well one thing, that shouldn't be XY, that should be Y1. There's part of your problem right there. That got us down to way fewer. It's not like this thing though. I don't think we can probably can't just access that, actually, in hindsight. We need to use something. We need to use the get tuple thing. I wish there was a way that I could just say compile it anyway. I wish there was a way. Can you turn this off somehow? I would love to, like, know if the rest of it compiles. I mean, I guess that means yes. Does that mean yes? I mean, we could... Okay, did we... Was it working back here too and just messed up because of this? Or is it also broken here? Is broken here. Okay. I think we don't want this. And I guess it's not print. Okay, so we have an object we're not using. Let's try to use it. I guess let's create a second one. Okay, now we have two tuple objects, both of which aren't being used. But we could try to like get a distance with that math.distance function. So that's going to return a float. Oh, okay. Technically, I guess it's going to return an obj t. We know it's going to be a float because it's right there. But I guess here we'll just make an obj t dist. Yeah, let's just do that, dist. Actually, let's call it line dist, because that's going to be the distance of the line. And it's going to be equal to all this, passing in le1 xy tuple, le2 xy tuple. So theoretically, we should not have the error about those tuples being unused, but we will now have one about this being unused. And we don't have an equal sign here. Okay, we need to include that somehow. By somehow, I mean pretty much just include it like that, just like we would anything else, I suppose. No such file or directory. Okay, I can't do H. No, I'm not. Shoot. I don't know how to do that. Okay, so here's where my lack of actually knowing C comes in. I don't even, can you import from a C file? Or include function .c file? Excuse me? Is that really 0 bytes? What the hell is that? This is kind of deja vu-ish, actually. I think I saw this once before. Well, it is 0 bytes. I don't like it. Wait, that's the question, though. Use double quotes, don't use angle brackets. Okay, that seems easy enough. Why it's better to use H files. We don't have an H file, though. Maybe the answer is create an H file. But for now, I'm going to change this and see if that works. Okay, that's really weird. So the last time we got that error, it just said implicit function mpmath_dist. It doesn't say did you mean. We had the fail one here where I tried to include an H file that didn't exist. And now we have implicit declaration, did you mean asyn? How does it know that asyn exists? I mean, that makes me think that the import succeeded, because that's a thing inside of here as well. So why did that succeed? And not the dist? One problem might be this, actually. One problem might be this, actually. We might need this. I don't need, can I just do that? Do we need this? Boy, this gets pretty far into the weeds, actually, because this means this won't be usable on any of the ones that don't have... Ugh, I don't know if this is gonna work. I don't know the right way to do this. Okay, for now, let's just wrap this and see what happens. I kind of don't have a very high sense of... hope that that's gonna work, but maybe. Actually, yes. That seemed to work. Okay, awesome. It does still believe that both tuples are unused. I mean, is that telling me this is not enabled? Is this not enabled? Oh boy, okay. Okay. Picture's becoming very clear now. We don't have this on this device, which I hadn't even considered before, but turns out this is the case. So this math.dist only works for things that have micropy py math special functions enabled, which must not be the case with this device, I'm guessing. Alright, well, I don't think we can reuse this math function very easily. Definitely not on this device. I don't know how, so like this is a Boolean somehow because it's part of this if thing, but I don't know how it gets turned on. I was kind of expecting to find some entries in boards, like ports, whatever, boards. And then that would set this to true or false. How's it going? Let's see, Exunium? I don't know if I got your name right. My apologies if not. Yeah, that's true. So I think I'm going to just abandon this trying to use math.dist. And instead, I suppose, it's not the most efficient thing in the world, but basically we're going to end up copying more or less this chunk of code and using it directly. You're doing Python, what is this? Yeah, good question. So kind of yes and kind of no. Currently we're inside the CircuitPython core. So if you don't know what CircuitPython is, it's a version of Python that you can use on microcontrollers, but and it lets you write Python code for your microcontroller. So like over here I have some Python code that is running on this device right here, although technically right now it's not really running. So we stopped it to go to the REPL, but we could restart it and then it would be running. Oop, as I punch the camera. So we have Python code that can run on the microcontroller devices, but the way that that works is it's actually because of CircuitPython, which is a C program, a fork of MicroPython, that implements that CircuitPython language. Like the Raspberry Pi Pico, more so than the big Raspberry Pi. Mostly this is for microcontrollers rather than like full Linux computers. Like the Raspberry Pi is basically a full Linux, what do they call that? PC, not really Linux PCB. I don't think that's not what I'm looking for, but it's a full Linux computer, system on a chip, SoC. Whereas these microcontrollers are much, much, much smaller, orders of magnitude smaller. Although getting bigger every day, every year, I guess. There are, like, to complicate things a bit, we do have like a compatibility layer that runs on Raspberry Pi computers, Raspberry Pi the big one, that does kind of let you write the CircuitPython code and run them on there as well. But that is kind of a secondary thing, not necessarily, it's not related to the C code which we have here. The C code here is the code that runs in the microcontroller in order to allow you to write Python code and save it on the microcontroller and have it run. So we have like kind of multiple layers at play. And then more specifically, I'm trying to make some intersection functions. So I was working on a function that will check whether a line contains a point. But in order to do that, we need to get the distance between the point and each end of the line. And then we need to compare those distances together. So that math.dist function is a way to get the distance. But it's a way that it turns out we can't very easily use. Way too much of a noob to appreciate it as it needs to be. I wouldn't say that too much. I don't think so. I mean, we're into some pretty deep stuff, so it's not stuff that everybody's using all the time, definitely. So. Okay. So basically what we're going to have to do is just kind of copy paste this distance stuff from here over into here. Unfortunately, we're ended up copying it 3 times, which is really rough. The good news is the silver lining news is, it's not even, I wouldn't call it good news so much, but the silver lining is we're not going to have to do all of this stuff. And in fact, we already have all of these variables, so we don't even need to create these variables. Really, we're just going to be doing this part only. Is that true? Okay, well, I'm less confident about the prior statement than I was when I said it, so I don't know for sure if that's all we need to do, but in the end, we are going to copy some of this, whichever part we need in order to operate on just the raw numbers, get back answers. Whereas a lot of this stuff is dealing with the fact that what we have here is not raw numbers, but instead Python objects, MicroPython objects that came in from Python land. Basically, we'll need 3 lines. We'll need this, and then we'll need this chunk from here, I think. So we'll need to get the distance between the x's that we're interested in, the distance between the y's we're interested in, and then we need to pass it into this to get the full distance between the points. And we'll have to do that 3 times. But we won't have floats, we'll have ints. Although we might end up with a float by the end. Okay. I do think it's going to be for a different time, though, because I'm going to head out for now. So, thanks to everybody who's watching. Thanks for the new folks we had in the Twitch chat, I mean. Feel free to follow if you're interested in this kind of stuff. I am usually on Saturday mornings, and then sometimes on Friday, but it's over on the Adafruit channel. Yeah, that's definitely true. Mysterious magic. I'm with you there. Hope everyone has a good rest of your day, and I'll see you later. Yeah, take it easy.